continuing with our examples. Example number 22, you see in your notes there, f of x is equal to the quantity 2x squared minus 5x plus 1, all cubed. All right, so we have an inner function that's being cubed. Okay, so let's do our derivative here. We're going to use the chain rule. So f prime of x, chain rule says derive the outer function. So we're looking at this saying, what's the outer function? The outer function is the cube. Okay, we're cubing something. We're cubing an inner function. So we're having inner function cubed. That means the outer function is the cube part. So how do we derive something that's being cubed? We bring the 3 out front and we reduce the exponent to 2. Okay, so we've derived the outer function. Now we keep the inner function. So we're going to keep the 2x squared minus 5x plus 1 untouched. Don't touch it yet. Okay, so we can see here 3 came out front, keep the inside function, new exponent is 2, so we derived the outer, we kept the inner, now we multiply by the derivative of the inner function. All right, the derivative of the inner function, now it's our turn to derive what we see inside the parentheses. Okay, so we'll have another set of parentheses, the derivative of 2x squared, nice and easy, 4x, the derivative of minus 5x will be minus 5, and the plus 1 derives to 0. And we're done. We don't need to simplify this anymore. Yes, we could combine the 3 and the 4x minus 5. We can make that 12x minus 15. We don't have to. What we cannot do, we definitely cannot do, is distribute the 3 into here. Okay, because order of operations tells us that squaring happens before multiplication. So you definitely do not want to make this 6x squared minus 15x plus 1 squared. That would be incorrect. Just leave it as is. It's a perfectly good derivative. With example number 23, we have the g of x is equal to the cosine of x squared. Now I didn't put this on the page, but we can certainly, we've got parentheses there. All right, we're taking the cosine of an inner function. If it was just cosine x, what would the derivative be? Yeah, it'd be the opposite of sine x. But it's not the cosine of x, it's the cosine of an inner function. So the outer function is cosine of something, and the inner function is the x squared. Okay. Keep in mind too, some former students of mine, they look at this, they think it's a product. They think it's cosine times x squared. That's not the case here either. You can't just cosine. Okay. You have to take the cosine of something. We can't just have cosine all by itself. Okay. So it's not a product. It's not cosine times x squared because cosine needs an extension. In this case, the extension is x squared. And that extension is more than x. So it's a function other than x, because x technically is a function, and therefore we want to use the chain rule. So let's go ahead and do that. All right, so g prime of x, okay, cosine is the outer function. We derive the outer function, and then we keep the inner function. So when we derive the outer function, the derivative of cosine, as we just mentioned, is the opposite of sine. Okay, keep the inner function, so it's the opposite of sine of x squared, and then we multiply that by the derivative of the inner function. What's the derivative of x squared? Good, 2x. So we have times 2x at the end. Okay. Now keep in mind, it's not x squared times 2x. We don't want to combine that to 2x cubed. That would be incorrect. The x squared belongs to sine. The 2x does not. What you will see in textbooks, online, on the exam, is this 2x usually is not going to be left out here. Where it's going to move, since we're a product and we know that order doesn't matter when we're multiplying due to the commutative property, it's going to move up front. So you would often see negative 2x sine of x squared. That would be an answer that you would see if this was a multiple choice question on the AP exam.